This is Unit 1, and we'll be talking about water today. We'll have another video that will be on water as well. So water is pretty fascinating. Water supports all life on Earth. All life on Earth requires water. Something between 70 and 95% of all living organisms are made out of water. Some things like jellyfish, it's probably closer to 95%. Like us, we're closer to 70%, but you get the idea. Of course, the Earth has lots of water on it. On Earth, water is the only substance that is found in all three states naturally, meaning it's found as a solid, it's found as a gas, and it's found as a liquid naturally. Water cycles through the environment very regularly. You can see here and from this picture, I mean, you've had water cycle before, I'm sure, but precipitation causes the water to fall on the earth, and water gets on the earth from other ways like humidity and other things, and then the water also evaporates back up into the atmosphere, causing clouds to form, and then precipitation. You get the idea. But then there's water underground as well, as you can see through here. The plants are also evapotranspiration, or you can just say transpiration from the land. That's the water coming up off the plants, and so water is constantly cycling itself through the environment. Water is a polar molecule. We spent some time in the last video talking about that, but just to review, the reason it's called polar is because it's an unequal sharing of electrons throughout this water molecule, whereas the oxygen end of this molecule is going to be this molecule here. We'll just use it as an example. It's going to be taking out most of the electrons, thus causing a slightly negative charge and leaving these hydrogen ends to have a slightly positive charge. And so we'll circle that just to be consistent. And so what's going on here? Well, this molecule here has a positive charge on its hydrogens. This molecule, the blue arrow, has a negative charge on its oxygen, and that positive and negative are attracted to each other, and therefore you have hydrogen bonds. What's the big deal with that? Well, one water molecule can form hydrogen bonds with 4 other water molecules. And so if you were to, let's say, attempt to take this water molecule and pull it out of that system, it would require quite a bit of energy to pull it out. Even though hydrogen bonds aren't all that strong, 4 of them are much stronger than 1. And so because of this, it causes water to behave in some interesting ways. Well, first of all, just because water is polar and has these slight charges, it does conduct electricity very well. And water is very much attracted to itself as well, which causes some interesting properties. The first of which is called cohesion. Cohesion is this idea that water loves itself and clings to itself. The best way to see this is to wax your vehicle and pour some water on it. That water will bead up. The reason it beads up is because it likes itself much more than it likes the wax, which the wax on the car is hydrophobic or non-polar. It is the opposite of water. It doesn't want anything to do with water. You've heard oftentimes oil and water don't mix. Well, the reason is because water is polar, oil is non-polar or hydrophobic, but they don't mix, so the water clings to itself. And in a similar way, the oil will cling to itself as well rather than mix with the water. Well, this causes some interesting things because, for instance, this tree, in a tree, trees are filled with lots of these little tubes called xylems. And the xylem is what is responsible for transporting water up to the very top of the tree. And so as that water is traveling up, the water at the top is literally pulling the water below it up the tree. And so this continues until the water will evaporate off the leaves. That water evaporating off the leaves is causing a force of pulling that is going up the entire length of the tree. You know, the water can't climb unless the water also likes the tree, right? It has to be able to stick to the tree. Well, there's another property. It's called adhesion. The idea that water sticks to other things is adhesion. Why does it do this? Well, going back to this, it likes the tree. Why does it like the tree? Well, there's something about the pieces inside the tree that the water digs, and it has a charge. A good example of this is go to the doctor, they draw blood, they take a little blood sample, and the nurse has this tube, right, and she's going to draw blood from it, and she takes the tube and puts it in the pool. She's not sucking the blood up with her mouth or anything weird like that. She just touches the tube to the blood, and guess what happens? The blood starts to fill the tube. Why? Because glass has this charge to it that water likes. Blood's full of water. The water goes up in the tube, so you have this cohesion adhesion thing working together. This ability of water to climb up these kinds of tubes like this is called capillary action. So we have adhesion. Another thing with adhesion too is that, I mean, we talked about how, I don't think we have talked about this actually, salt and the sodium chloride, sodium will ionize by losing an electron, chlorine will gain one. And so notice sodium has this positive charge, chlorine this negative charge, and what do you think happens? Well, the positive parts of water surround the chlorine, the negative parts of water surround the sodium, and it separates them, causing the salt to dissolve. And you see this picture of that, causing these are called little hydration shales around the pieces, causing it to dissolve. You take all the water out, you evaporate the water out, what are you left with? You're left with salt. A couple other things on how water behaves. Water is able to store a tremendous amount of energy. Why is that? Well, again, it's like pulling that middle one out. If you add energy to water, say in the form of heat, those water molecules will start to move around and get a little more excited. But water has an extremely high boiling point compared to other liquids. Why is that? It's because water does not want to separate very easily from each other. And so, take the earth that has a lot of water on it. The sun shines on the earth really hard during the day. On one side, the sun is shining on the earth here in the Indian Ocean and the Pacific, or the Atlantic and the Southern Ocean there. And as that side of the earth flips around to the other side, rather than freezing, it's nice and warm at night because the ocean then releases that energy that it's been storing all day back out to the atmosphere, keeping the earth warm. There's some other ways that this sort of thing helps. Well, there's ice. What happens to ice? Ice, we oftentimes think of ice as cooling a drink off. We use ice to do that. Well, what's going on? The energy that is in the water is actually melting the ice, is raising the temperature of the ice, and so all that energy that's in the water escapes, causing the water to cool down. What about in our own bodies? We're made of 70% water, right? So if we need to cool down, what's the best thing to get rid of? Something that stores lots of energy. We get rid of water. And there we have Andre Agassi playing tennis. Very few people know who he is anymore, but there he is, and he's sweating. He is cool. His body's attempting to cool off by sweating to get rid of all that energy, because water stores a lot of energy. You sweat, you get rid of energy, and then a double effect is this idea of evaporative cooling, which the water on your skin evaporates off, giving you this cooling effect. people that live in this part of the country don't really get this because of the humidity in the air. There's so much water in the air already that the water doesn't actually evaporate off of our skin. It just kind of stays there. There's the same idea in plants. Moving on. So what happens about water when it freezes? Well, we all know that water expands when it freezes. It put a glass water in the freezer and you leave it overnight, come back, the glass will be shattered because that water has expanded. Why does it do that? Liquid water looks like this, and this angle right here is 105 degrees. When water freezes, that angle shrinks to 90 degrees. Now, what does that cause to happen? It causes those molecules to want to push away from each other, and it causes the water molecules to push away, causing the water to expand. So this does a couple of things. The mass of the water hasn't changed because you still have the same amount of water. However, that water is now taking up a larger volume. And so what happens to the density then, if mass stays the same, but the bottom number, volume, increases? Well, the density is going to decrease. Therefore, ice floats in water. And so as the water expands, freezes, ice will float. This is good because things like lakes, the water freezes on top, thus saving the wildlife that is underneath. And so many ecosystems, like this frozen lake, for instance, depend on the fact that their water underneath is actually relatively warm compared to the outside temperature. The animals underneath and the plants are saved from the winter simply by being underwater.